So thank you so much to everyone to join in. Today we are here to talk about how to use IoT data to deliver better customer experiences. My name is Adrian Valenzuela. I am responsible for IoT business development. I'm the worldwide go-to-market specialist for all the connectivity and control services here within AWS. And I'm joined today here by Sanika. Would you kindly introduce yourself, Sanika?
So my name is Sunika Natu. I am the IoT Solutions Architect Specialist, working with Adrian on presenting on how to use IoT data to deliver better customer experiences.
Perfect. Thanks so much. So I'm going to quickly give a high-level overview about what we're going to talk about for a few minutes, and then I'm going to hand it over to Sanika, who's the brains of the operation, and she's going to go into a really hands-on demonstration of how to actually implement some of these solutions in a real-world setting. So let's go ahead and jump forward to our agenda. So we're going to talk about a few things. I know we're all familiar with the IoT, but we're going to talk about some of the really common IoT use cases that commonly impact the customer experience. Obviously, not everything is directly consumer or customer facing. Some things are tucked away on the back end. So we're going to focus today on very consumer oriented experiences or products that impact a user. We're going to go into some of the common IoT challenges that impact those customer experiences. There's a lot of things that impact the back end on the development and product side that ultimately ripple down into what the user ends up seeing. From there, we're going to go into what AWS brings to the table. What are the IoT solutions available that can help put these things all together? And how we'll show how to do that. And then where we're going to spend the bulk of our time is actually a demonstration. We're actually going to set up a lot of the real world features and capabilities that we'll talk about at the high level up front. We'll implement them and show how they all can be put together to solve real world problems. After that, we'll open up the floor for Q&A from everyone. So there is a lot of different use cases that we've seen that impact the customer experience. And our customers, our AWS IoT customers, are innovating in just about every part of the consumer's life. Um, Here we have a sampling of a pretty wide set of applications that we've seen our customers go implement. Let's start with highlighting a couple of them. First off, there's home automation. This is really the bread and butter of most connected home product solutions. Consumers want their smart products to not only connect to the internet for direct command and control use cases, but also to interoperate with other devices in the home. Using AWS IoT, you can enable any device to connect to the internet and perform a desired action quickly, reliably, and easily. These devices can work alone or together with other devices. You can work with hubs for an integrated smart home experience. Additionally, customers can also easily produce devices with Alexa built in through Alexa voice service integration or add in what's called works with Alexa functionality through Alexa skills. So we can add a seamless voice controlled customer experience. Probably the second most common use case for IoT in the home or consumer facing is security and monitoring. Devices like door locks, security cameras, and water leak detectors built with AWS IoT can use machine learning to automatically detect threats, take actions, and send alerts to home users. AWS IoT enables devices to run with low latency and compute data locally without internet connectivity. We have customers like Wise who built their entire IoT infrastructure with IoT and other AWS services like Kinesis Video Streams or KVS. And now they've scaled to millions of devices sold worldwide. And they did all that within just a couple of years. They've been able to keep costs really low and offer value added services such as subscription packages to store video data for longer periods and live video streaming through a mobile application. Networking is also a really common use case for IoT. Network operators are looking for new ways to help consumers quickly discover, troubleshoot, or even fix home issues, including Wi-Fi and cable TV connectivity. AWS IoT enabled set-top boxes can automatically log network diagnostics and send it to customer service centers proactively, or allow customers to monitor and troubleshoot their network health through a mobile app. From a consumer perspective, we've all faced the experience where you get a time window from 8 a.m. to 12 p.m. Where a technician's going to show up. You don't know when they do, they might not come. That's a very frustrating experience. By having these things connected to the cloud, you can completely eliminate on-site visits from a technician, which allows the consumer to just go on with their day. Energy management is one of the other really common things that consumers are opting for in their smart home. There's much more to home energy management than just a smart thermostat or HVAC systems that we're probably all familiar with. Building an energy efficient home also requires making changes to appliances and systems in the home that are using energy in the form of electricity, water, and gas. Our customers build products that communicate their energy consumption data back to the cloud and can be surfaced as insights to the end customer about how their electricity, let's say their dishwasher, is being used on a given day, or if there's been a spike in water usage in the basement bathroom, which could mean that there's a problem afoot. Maybe there's a potential flood risk. These insights could also be made actionable, such as scheduling your dishwasher to automatically run at night when energy costs the lowest, or by remotely turning off the water valve if you're out of town and your hot water heater has blown up. And finally, the last area that I'd want to talk about is health and wellness. Especially for the course of the last year or so, our home has expanded to be our workplace, our gym, not just the place that we sleep. There are even more opportunities to connect personal health and wellness devices. This spans from medical sensors such as heart rates and blood pressure monitors, medication packaging that monitors if a patient opens them at a desired time or not, or lifestyle wellness trackers like smart scales or fitness wearables, or even a toothbrush that tracks your usage and tells you if you brushed a particular region of your mouth sufficiently. We have other customers like Peloton who are building fitness equipment like spin bikes and treadmills to keep us healthier without ever even having to leave our homes. So those are the very common uses. Let's transition over to some of the challenges we've seen with these use cases. Across all of the different customers that we've helped connect their devices to the cloud, we've seen a consistent set of patterns come up with connected consumer products. Let's walk through a couple of the patterns we see on why these challenges apply to connected products and how working with AWS IoT can not only mitigate those issues, but can create opportunities to add value for your end customers and how to improve their customer experiences. Probably the first one that impacts the development of a connected product is managing and scaling large fleets. This is almost always the largest concern for our customers who expect to see a large increase in their fleet size, whether it be, thousands or even millions of devices. Management of the device is complicated because you can no longer address devices individually. You have to think about how to deploy them and manage them at very large scale. Managing a fleet of millions of connected devices requires a different process to minimize that manual intervention. AWS provides the back-end infrastructure to ensure that even massive spikes in growth won't be limited by your back-end infrastructure. AWS provides the tools and services to simplify device management and allows you to focus on innovating in your core business. Probably the second most common problem is managing security and privacy. Here at AWS, we like to say that security is job zero. Keeping data secure, data protected, and most importantly, keeping customer information away from prying eyes is a top priority for most of our customers as well. We have a shared experience to keep devices, IoT data, and customer information secure and protected from threats to minimize from losing trust with our customers. And finally, the customer experience and support is crucial to building your brand. Any experienced company who has released a connected product at scale knows that getting a product developed and launched is just the beginning of the journey. After a product gets into consumers' hands, those products have to be supported nearly indefinitely. Things go wrong. Customers have issues. Devices need to be updated with new features or fixes. AWS can help with the capabilities to not only remotely debug devices regardless of the network configuration, but they can also give you a head start on customer support by knowing the state of all the devices in the field before the customer even calls. So let's jump into just one component of these. An often overlooked challenge by the development team who's bringing connected products to market is that long-term vision to build in the capabilities to support customers easily when products are in the field. Customer trust is invaluable in consumer products, and when things go wrong, you have an opportunity to delight them with phenomenal customer service. Because you're able to monitor fleet health in near real time, you can preemptively push updates and patches to devices before the consumer even knew that there was an issue. This will result in higher product uptime for the customer. When issues do arise, it's possible to remotely troubleshoot devices through AWS IoT secure tunneling, for example, which gives you access to a device even when it's tucked away behind a firewall. This will ultimately save you time and money by avoiding a costly visit from a technician to a remote location like the customer's home, or having to deal with physically mailing a problematic device back and forth. When customers do have to call in for support, that call can be shorter since you already have all the usage history and the current state information for a given product. Things like information that we store internally, like device shadows or device indexes, provide state information even when that device is offline or doesn't have network connectivity. No need to ask the customer to dig through hidden support menus or try to reproduce the issue while you have them on the phone. You already know the state of that device. And most importantly, because we have a lot of infrastructure to display that information for your internal team, you don't need to have highly technical staff to debug that issue. You can graphically view that on a web console internally, which will ultimately reduce your cost burden with being able to support them with non-technical staff. So let's dive a little bit deeper into the specific IoT architectures that are used in connected consumer products. Sanika, can you take over from here?
Sure. Thank you, Adrian. So, Adrian talked a lot about the various challenges of connected products, diving more specifically into boosting productivity with customer support. And before I go into how AWS enables customers to solve those challenges, I'll talk first about how AWS approaches IoT engagements. We typically think of the IoT architecture in three layers. The first layer is device software, and this answers the questions that customers typically have around how can I build devices that operate at the edge? The second layer is the connectivity and control services layer. And this layer answers the questions customers have around how can I control, manage, and secure my devices at scale. This becomes really important when our customers have millions of devices that they have to operate, manage, and organize as they grow. And then the last layer is the analytics services layer. And this layer answers the questions our customers have around how can I make sense of IoT data and take appropriate actions? How can I reason on top of the data that I ingest? And while this architecture is typically thought of as a layered one directional architecture, here at AWS, we like to think of it as a virtuous cycle. And we answer these questions that these customers have at these various layers with various features that we provide through AWS IoT services. So at the device software layer, we enable customers to securely build devices that operate intelligently at the edge, but more importantly, connect to AWS IoT by default with minimal development and management on the customer side. At the connectivity and control services layer, we enable customers to connect their devices to the cloud at scale and keep them healthy and secure and allow them to integrate with other AWS services as well. And finally, at the analytics services layer, we help our customers make sense of their IoT data and take actions to solve business problems by integrating with various machine learning, database, and compute services in the cloud. And we do that with providing the following features. So at that device software layer, we really focus on connecting and provisioning devices, as well as operating and allowing for device security at the edge. At the connectivity and control services layer, the focus is around onboarding devices, providing cloud security, and finally organizing and managing those devices at scale. And at the analytics services layer, we focus on providing the applications that allow for data management, event detection, remote monitoring, and finally data security so that our customers can make sense of their data. Shown here are the various AWS IoT services that accomplish those features that I've just mentioned. And some key services that I'll be highlighting through the rest of this presentation and this demo are the AWS IoT Device SDK that operates at the device software layer, the AWS IoT Core, AWS IoT Device Defender, and AWS IoT Device Management Services at the connectivity and control services layer, and the AWS IoT Analytics Service at the analytics services layer. So let's go ahead and take a step back and look at how these devices work together in a customer implementation. Our customers are looking to connect their devices, whether they're microcontroller-based devices or high-performance processors. Microcontroller-based devices can be devices such as door locks, light bulbs, or small appliances. And these microcontrollers can either directly connect to the AWS cloud, or a gateway, such as a Wi-Fi router or home controller, can batch data, aggregate data, and run analytics on that data before sending it over to the AWS cloud. Once the data has reached AWS IoT Core and has been ingested, the possibilities open up with what you can actually do with that data. Our IoT services such as AWS IoT Device Management, AWS IoT Device Defender, and AWS IoT Events allow you to manage, control, and secure your devices and manage and ingest data at scale. Finally, data can be routed to back-end AWS products and services that our customers are familiar with and use on a regular basis, such as machine learning services, database services, and compute services, so that data that is ingested once in the AWS IoT Core service can be sent to any other service. And finally, we have customers that are looking to develop customer-facing apps to provide multiple ways to interact with their products. These can be mobile apps, dashboards, or even Alexa devices that offer new and innovative ways for their user base to interact with the data coming from their IoT devices. We have a wide range of customers that are using AWS IoT Core and AWS IoT services, but one example is Vizio. And Vizio is the #1 American-based smart TV brand in America that has connected millions of smart TVs to AWS IoT. With AWS IoT, Vizio is able to deliver continuous updates and features to their devices. They heavily look at fleet health information to help remotely troubleshoot and solve problems for TVs in the customers' homes who are experiencing issues. By knowing the state of all TVs in real time, they can anticipate when a customer needs support and can send technicians or remote operators to sites proactively or be able to remotely diagnose any issues as they occur. A quote from the Vizio CTO, Bill Baxter, is AWS delivered an end-to-end IoT solution that enabled a secure and scalable implementation. We were able to deliver a working prototype within a couple of days. And that's where the value of AWS IoT lies. Being able to provide the building blocks to satisfy and accomplish your IoT goals and quickly spin up solutions that allow you to deliver a better customer experience. So now that we've taken a step back, let's go a bit deeper into a real-world example. Here, you'll see an architecture that our customers use when it comes to developing IoT solutions to solve their use case. Let's imagine that you're a manufacturer of connected water dispensers in building offices. You're managing a device fleet of millions of devices across the country, and these devices are using the AWS IoT Device SDK to directly connect to AWS IoT Core. These millions of devices are sending telemetry to AWS IoT Core as an ingestion point. Once this data is ingested within AWS IoT Core, the customer now has access to various AWS IoT services to make more sense of their data. AWS IoT Device Defender lets you look at cloud metrics and device metrics and sends notifications to the appropriate representatives, technicians, key business points of contacts to ensure that the appropriate people are notified when issues do occur. Those cloud metrics or device metrics can be the number of messages that our devices are sending to IoT Core. It can also be the number of disconnects across your fleet of devices. And it can also be more security specific, such as security credentials that are shared across your fleet of devices or even expired security credentials. Through the AWS IoT Rules Engine, you are able to route your data to your backend AWS services and third-party applications. These could be dashboards that you've developed, or it can be machine learning or database services that you'd like to integrate in your entire solution, and that's done through the AWS IoT Rules Engine. You finally have a number of IoT device management services, such as AWS IoT Device Management, which allows you to send over-the-air updates to your devices through the use of IoT jobs. You have AWS IoT Fleet Hub that provides a managed web application for monitoring your entire fleet of devices and quickly diagnosing issues when they occur, and secure tunneling capabilities that allow your fleet operators to remotely access devices without having to go through costly in-person site visits. So with that, let's go ahead and dive into a demo to demonstrate these various components. We'll start with the notification I received last night from AWS IoT Device Defender. I received an email about a number of disconnects that were happening with my fleet of devices. I have a subject titled Disconnect Alarm, and immediately I see that the security profile name is called Device Defender Disconnect. I've created this beforehand, and I'll go into that security profile in more detail. Now I'm back in my AWS IoT console, and to get more information on that security profile, I'll go into the Defend section of the AWS IoT console, and I'll go into the Detect section. I've created a security profile prior to this, which defines anomalous behaviors for a group of devices or for all of devices in your account. And this specifies what actions to take when an anomaly is detected. So I'll click into my security profiles, and I look at this security profile that I've created that sent me the notification, Device Defender Disconnect. When I click into the security profile, I'm reminded of the behavior that I've identified, and this is a disconnect behavior. It tells me that whenever across my fleet of devices there are a number of disconnects that are greater than 5, I will be notified with an alarm. So coming back to this architecture, through the AWS IoT Device Defender, I've now been notified that there is a security issue with the number of disconnects that are happening across my fleet of devices. And now what I'd like to do is I'd like to diagnose what those issues might be. I don't have visibility at this point in time as to why those devices are disconnecting. So I'll look at AWS IoT Fleet Hub for a managed web application to remotely diagnose these issues. This is the AWS IoT Fleet Hub managed dashboard. On this page, we have a summary view of all of the devices that have been rolled out across the country. I have a view of the total number of devices. I also have a view of the number of connected devices. And I also am able to see the various device types as well as device groups that I've set up for my number of devices. I see that we have some devices that belong to New York City, some devices that have various versions of firmware, and I see this all through my summary view. I see a couple of disconnect reasons as well, and this is where I want to dive a bit deeper into. I see that 29% of my devices have lost their connection, and I see that 2% of my devices have initiated that disconnect themselves. So with that, I'll go ahead and click into the device list to get more details onto the issues that are occurring. Here, I see a detailed view of all of my devices. I have access to the device name. I have access to whether that device is currently connected or not. And I also have access to various attributes that these devices are sending. Some of these attributes are the battery state of charge, whether that's 90%, 30%, or 10%. And it can also view the firmware version, the location, and the temperature. I can see already that some of my devices are disconnected, and I'd like to drill a bit deeper in here. I'll go ahead and add a filter. Select field is connected and value is false. And when I apply this filter, what this will show me are the total number of devices that have been disconnected. So the connected field is a false value. So I'm going to go ahead and apply this filter. And I now see the number of devices that have been disconnected. At first glance, I don't notice any trends. I see there are a different number of battery percentages across these fleet of devices. I see that locations are spread out across these devices in San Francisco, Boston. I see various temperatures that have been reported. One trend I've noticed, however, is that the firmware version is 0.1 across many of these devices. To go ahead and confirm my hypothesis, I will go ahead and clear my filter and search on devices where the firmware version is 0.1. When I search on these devices, I will be shown a list of devices where the firmware version is 0.1. You can already see that almost all of these devices have been disconnected, and it's quite possible that because this firmware version was the oldest firmware version, the devices did not receive some sort of update to allow it to continue to connect to IoT Core. So I want to make sure that this doesn't happen across my devices that are currently connected that might be operating older firmware versions. So I'll go ahead and clear this search, and I'll search on devices where connected is true. I'm now shown a list of all of my devices that are currently connected, and I'll select these devices and run a job so that I can update all of these devices with potentially old firmware so that these devices are now updated to firmware version of 2.0. So I'll go ahead and update firmware version to 2.0, and this will be a snapshot job, so my job will complete after deploying to those selected devices, and I'll go ahead and run that job. So as we wait for that job to execute, we will go back to our architecture, and we'll show that AWS IoT Device Management provides that over-the-air update mechanism through Fleet Hub so that customers have an easy way to send updates to devices when they need to update firmware or any other device characteristics. So we'll go ahead and refresh, and we can now see that all of those devices have now been updated to the new firmware version. So now that we've resolved that issue, I noticed when we were previously looking at these devices that there was one more issue that I'd identified. I know that the temperature that's being reported from these devices is in Celsius, and 100 degrees Celsius in Atlanta seems way past the thresholds that we've defined for these devices. I want to check whether this has occurred across multiple devices or if this is just one single device that's been affected. So I'm going to go ahead and search upon these devices. And I see that 3 devices have been affected and are reporting these very high temperatures of 100. What I'd like to go ahead and do is create an alarm for these types of devices so that my remote technician can be alerted and can diagnose and access those devices to troubleshoot the issue. So I'll go ahead and create an alarm. Here, the target query has automatically populated where the reported temperature is 100. And what I'll do here is I'll choose an aggregation type where the count of a searchable field, so in this case, the temperature field, over a period of 5 minutes will be aggregated. And this essentially shows that we will group devices over a period of 5 minutes that have a temperature of 100. We want to define a threshold for that number of devices that have a temperature of 100. So we'll just say that whenever the number of devices with a temperature of 100 is greater than 1, we want to notify the appropriate technician. I'll go ahead and press next. And here's where I would fill out an email list name as well as the list of email addresses that will receive the notification. I've already gone ahead and created this alarm, so we'll dive a bit deeper into this alarm. And we'll see that this alarm was already created for when a temperature was greater than 90 degrees Celsius to send an email to a list of recipients within the technician email list. We'll see this graph that shows the number of devices that have been affected and have crossed this threshold. And we'll even have visibility into the exact devices that are reporting these 100 degrees Celsius temperature numbers. So now we've been able to show that AWS IoT Fleet Hub is able to provide the monitoring mechanism to view your fleet of connected water dispensers at scale. We've been able to be notified when disconnects across your fleet of devices have occurred, and we've been able to diagnose why those devices were actually disconnected, as well as even identify issues outside of the disconnect issues that were happening. The last thing that I'd like to check is that the data that users have access to is showing up correctly and they still have access to their dashboards and applications. Here, we'll look at the AWS IoT rules engine that provides the integration with backend AWS services. So coming back to our AWS IoT console, we'll go under the Act section of the AWS IoT services. Here, we'll see a link to the rules that we've created that allow us to route data from AWS IoT Core to any other service that we define. I've already created a rule that will route the data, and if I click into this rule, we see that we are selecting various device attributes from AWS IoT Core and sending that to AWS IoT Analytics for additional processing and generation of a data set that our backend services can use. AWS IoT Analytics provides an easy integration with analytics capabilities and provides data sets that you can integrate with services like Amazon QuickSight for visualization. I'll now dive deeper into the Amazon QuickSight dashboard so that we can ensure that users still have access to their data and their applications. Here, users can see their number of devices across the US. We see that we have a number of devices in California, Illinois, Georgia, and we also have some visualizations with the number of devices with low battery, so our customers are able to have visibility into the devices that they'll have to recharge. And we have some visibility into the devices that have stopped reporting, as well as the temperature across the past day. So coming back to our architecture, We've been able to demonstrate how our customer is able to have visibility into their device fleet of millions of devices, that our customer has access to the data that's being ingested in AWS IoT Core, and can monitor various security configurations or even diagnose issues that are occurring at the device level. With AWS IoT, we provide the building blocks to let you easily, quickly, and efficiently create IoT solutions for whichever use case that you have. And with that, I'd like to open it up to any questions